I need to get my book. Do you remember us having a conversation about how to prepare for a test and you need to work on your test taking and all that? So if I were studying for this test, what I would do is I would turn off my phone. I would get into a nice quiet location. I would take out my formula sheets, my calculator, some ibuprofen, and my favorite beverage. And I would sit down and I would pick this thing right here, take this sheet, and I would just pick a problem. And I would just take that, circle it, find it, and see if I can do it. And if I can do that problem without prompting, without any sort of, needing to look through the notes, then I think I'd feel ready. Now, the only issue with that is you're going to know what section it's from by looking in here, right? So you might want to try maybe writing some of these problems down in like a mixed order, and then just trying to work off of that. So that way you don't know what section you're in. Because that kind of gives it away a little bit, and that's something you don't have on the test, is something indicating what section it's coming from. So just have to practice it. I need my book. You said what section or what page? 595. Oh, okay. Number what? Number 20?
You have 19 through 23.
595. I don't see 595. Oh yeah, there it is. Yes, you're not lying to me. All right. 7 points, page 595, 19 through 23. And you want me to do which one?
Number 20.
Number 20, 1/2 cotangent? Okay. 1/2 cotangent of 2x minus pi. All right, let's see if I can remember how to do this. All right, so we are graphing a cotangent function. This is the instructions here are to sketch the graph. And on a final, it would be use the techniques in class that we learned in class to sketch this. So do you remember how we graphed cotangent? We set the argument of the trig function equal to 0 and pi. What if this was tangent? We set the argument equal to -2 pi, or negative pi over 2 and pi over 2. That's right. Now, if you didn't remember that, on your pictures, let's see, do you have pictures? No, I thought that your reference sheets had the pictures of, oh, here they are. Yeah, can I use this real quick? On reference page 2 of your formula sheets, it has the graphs of sine, cosine, tangent, cosecant, secant, and cotangent. And since cotangent is there, you can see what cotangent looks like. The cotangent function looks like this. It has vertical asymptotes. It looks a lot like tangent, but it's backwards, like this. Oh, I missed it. That's supposed to go through like that. And this vertical asymptote's at pi, and this one's at 0. So what I'm getting at is you would know to set this equal to 0 and pi if you looked at the graph and identified that one period of the cotangent function goes between 0 and pi. Otherwise, you just have to memorize it. So I take 2x minus pi, I set it to 0. I take 2x minus pi, and I set it to pi. So on the first one, when I solve for x, I get pi over 2. Moving the pi over, dividing by 2. Here, when I add pi to both sides, I get 2x equals 2 pi, and that means x is pi. That fair? That good? So that means my graph, like if this is the y-axis, if that's 0, my graph is going to start at pi over 2 and end at pi, and I will have vertical asymptotes there. Now with cotangent and tangent, I said not to worry about this piece, other than the fact that if it's negative, it would flip it over. Otherwise, don't worry about it stretching it out, because you don't really have an amplitude like you did on sine and cosine. It's hard to like visually see a stretch. So all I would want here is for you to recognize that because this is a positive number, it's still going to look like this, and you need to find that point in the middle, which is just the midpoint of those. So what's the point that's right in between pi over 2 and pi? 3 pi over 4. And you can find that by adding them and dividing by 2. Okay? But then all I want is this. And that'd be it. You'd be done. Is that okay? All right? Okay. Anything else from that section or from that graphing? Anything else from anywhere else?
2.4.
Page 186, number 27. We have x squared.
What number was it?
This is number 27 on page 186. Plus y squared minus 2x minus 4y minus 4 equals 0. All right, so you know what to do? You're asked to find the center and the radius of this circle and to sketch it. So what do you have to do? You got to complete the square. So this is going to be just like the ellipse and parabola problem, where you have to actually complete the square for both the x and the y in this case. So I group my x's together, I group my y's together. So for this first group of my x's, I'm going to take half of the number in front of x. What's half of the number in front of x? -1, and I'm going to square it, which is 1. And I'm going to add and subtract. Do I need to show that, or are you all okay with that? You all right? Don't need? Go ahead and show it. Okay, so I'm taking the -2 here. I will always take half of it, which will give me -1. And then you take that answer and you square it, which gives you 1. And that's kind of your magic number. You're going to add 1 and subtract 1 right next to this. So x squared minus 2x. Here comes my magic number, plus 1 minus 1. And now I need to do the same thing for the y's. So plus y squared minus 4y. I'm going to take the -4. I'm going to take half of it, which is -2. I'm going to square that, which is 4. So I'm going to add and subtract 4. You always add then subtract. You never subtract then add. Always add then subtract. And I still have -4 there. So the blue is the part that I'm introducing. That's my hidden zeros. Questions? These first 3 terms will guarantee factor into a perfect square trinomial. And these 3 will guarantee factor. So what do these 3 become? X minus 1, that quantity squared. But I still have what next to it? -1. And then here, this will guarantee factor to be y minus 2 squared. That's y minus 2 squared. And then -4 and -4 still. And this is now x minus 1, that quantity squared, plus y minus 2, that quantity squared, and then all my numbers together, I get a negative 9 on the left side. So I'm going to move it to the other side, and that'll be equals 9. And that's what circles look like. This looks like x minus h squared plus y minus k squared equals r squared. Why is this not an ellipse? So if this were 1, right, I would have to divide the 9, and this would be divided by 9, this would be divided by 9. But if they're divided by the same number, it's not an ellipse. For the ellipse to happen, the numbers underneath these had to be different. If they're the same number, then it's a circle. So there's my circle. Center is 1, 2. Radius is what? 3, right? Be careful. Don't use 9, right? 9's not the radius. That's the radius squared. So your radius is 3. So I would go and draw a circle. I go out to the right 1. I would go up 2. I put my center, and then I just draw it with a radius of 3. Next.
So, 8.5, page 652.
Mm-hmm.
38.
38. I was hoping someone would ask something like that. I won't ask you for intercepts. Does the book ask you for intercepts? X-intercepts and y-intercepts? How would you find the x-intercepts?
Like 0, set x equal to 0.
Uh-huh. And then y equal to 0, and then solve it. It'll be just a quadratic. It should, yeah, it should work out. All right. All right, so for this one, this one could take a while. But you're asking me number 38, right? So they give you tangent of alpha is 5/12. They give you that pi is less than alpha is less than 3 pi over 2. And then you're also given that sine of beta is negative 1/2. And that pi is less than beta is less than 3 pi over 2. So that's all given to you. And you're asked for 4 different things here. You're asked for sine of alpha plus beta. What else? Cosine of alpha plus beta?
Yes, sine of alpha plus beta,
Uh-huh.
sine of alpha plus beta,
Uh-huh.
sine of alpha minus beta, and tangent of alpha minus beta.
Those are the 4 things you're asked for. All right, if I'm going to try and find sine of alpha plus beta, I have a formula for that, don't I? Sine of alpha plus beta is sine of alpha cosine beta plus sine of beta cosine alpha. It's on your formula sheets. If I want to know what cosine of alpha plus beta is, that's cosine alpha cosine beta minus sine alpha sine beta. If I want to know what sine of alpha minus beta is, I have a formula for that. And tangent of alpha minus beta, well, there is a formula for that also. All of the formulas that I use require that I know what sine of alpha is, what cosine of alpha is, what sine of beta is, and what cosine of beta is. Okay? So what we did to do these problems is we used this information to create two reference triangles. The reference triangles will give us everything we need to know about alpha and beta. So let's start with this one right here. Well, that goes with this information also, all right? So I would start this by drawing, not a unit circle, but just breaking up my quadrants here. And they tell me that I must be in which quadrant? Alpha must be in which quadrant? Third quadrant, right? I've got to be between pi and 3 pi over 2, so between here and here. So I know that I'm not in here. I know that I'm not in here. So I could draw my little reference triangle like this. Now, keep in mind that if you draw your reference triangle like this, that what do my x and y coordinates have to be if I'm in that quadrant? They both have to be negative, right? Like if I'm here, right, to get to this point, I have to go negative on the x and negative on the y. Tangent of alpha is the y coordinate divided by the x coordinate. So you might be thinking that this is the y coordinate is 5 and the x coordinate is 12, but that would be incorrect. Right? That's incorrect. They both have to be negative because you're in the third quadrant. Does that make sense? Now, that has no impact on the hypotenuse because you're going to do this squared plus this squared equals this squared. But it does have an impact on if you're asked what sine of something was or cosine. Because sine would use this number, sine would use this number, cosine would use this number. And if you have those as positives instead of negatives, it'd be wrong. So is that clear?
So if you ask for sine?
We're gonna need what sine is. We'll get it. Let's get the hypotenuse first. So we do this squared plus this squared. So that's 144 plus 25, blah, 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 square root is 13. All right, now the hypotenuse is positive, always. So we good with this? Sure? All right. Now, from this information, let me just write down all the things I know. Sine of alpha, cosine of alpha. Tangent of alpha I already have, don't I? So what is sine of alpha? Negative 5 over 13. And what is cosine of alpha? Negative 12 over 13. Why do I need that information? Because in my formula, right, for sine of alpha plus beta, I need to know what sine of alpha is. So that's why I'm getting this now, right? So we're going to build up all the information first, then we're going to go over here and plug everything in. That should be all I need for that. All right, now let's do this one. I'm in the same quadrant, aren't I? Kind of boring, but there we go. So I draw another triangle. And I'm given sine of beta. So all of this had to do with alpha. This one has to do with beta, right? I'm given that sine is negative 1/2. Sine is the opposite or the y coordinate over the hypotenuse of the radius. So my y is going to be negative 1, and this will be 2. And does that make sense? Should I keep that a negative 1? Yes, I mean that's going to be negative 1 because you have to come down to get to this point. And then the hypotenuse is 2, is always going to be positive. So that's good. We just need to find the x coordinate now so that we can know what cosine is. So you would do like whatever this is squared plus this squared equals this squared. So we'll call that thing x. X squared plus negative 1 squared must equal 2 squared. So x squared plus 1 must equal 4. And that means that x squared is equal to 3, which means x is plus or minus root 3. And which one is it, plus or minus? It's minus because, again, we had to go into the third quadrant. So x is negative root 3. Everybody clear on that? Now, how am I going to use that information? For the cosine part, right? I already know that sine of beta is negative 1/2. But now I also know that cosine of beta is negative root 3 over 2. Adjacent over hypotenuse. And that should be everything I need. Questions? All right, let's answer part A. So for part A, I use the formula that sine of alpha plus beta equals sine alpha cosine beta plus sine beta cosine alpha. I know that some of you are using the formula different, like you're flipping these, and that's fine. It doesn't matter. Multiplication is commutative. All right, so now we have all this information. Sine of alpha is negative 5 over 13 times cosine of beta, which is over here, that's negative root 3 over 2, plus sine of beta, which is negative 1/2, times cosine of alpha, which was negative 12 over 13. So that gives me positive 5 root 3 over 26 plus 12 over 26. Negative and negative become positive, so we have the same denominator, so we can say 5 root 3 plus 12 over 26. And that's the exact answer. Do you think you could handle the rest? I mean, just plug in the formulas? What about the tangent of alpha minus beta? What formula would you use for that one? I mean, there is a formula on your formula sheet, right? What is the formula for this one?
Tangent of alpha minus tangent of beta.
This one? Yeah, what is it?
Tangent of alpha minus tangent of beta.
Ooh, okay, yeah, we can do that. Tangent of alpha minus tangent of beta.
And then it's over 1 plus tangent of alpha
1 plus tangent of alpha
times tangent of beta.
times tangent of beta. Ooh, beta. All right, so we could use that formula for this one. We never wrote down what tangent of alpha and tangent of beta were. So let me do that over here. Do we know tangent of alpha? Oh yeah, we were given tangent of alpha. Oh, that's nice. Do we know tangent of beta? We could find it by just looking at the triangle, right? Tangent of beta is going to be this over this, right? Opposite over adjacent. Negative 1 over negative root 3 is just 1 over root 3. Negative and negative become positive. So then you just plug everything in over here. Is that good? Is that sufficient? Okay. All right, anything else? Anything else kind of popping out at you going, uh-oh? What do y'all want to do on Thursday? Pizza party? How about, I was thinking what might be useful is that, like, I come into class and I present you with maybe like 10 problems and give you an hour to work them. Like totally, like almost like a testing environment. Like the first hour you just see how you do with what I present to you.
And it'll be a bonus for the final?
No. It'll be a bonus in the terms of it'll help you. It's to help you see where you are. So what do you think? Give you a little 10 problem, 1 hour, see what you do with it? And then afterward we can talk about it. But I mean, the thing about that is it's only 10 problems, you know, out of 75 potential problems. But at least it'll be something that will give you an indication of where you are if you're really ready. Because if you have trouble with 10 problems, on Thursday, then you know how much work you've got ahead of you getting ready for the final. The final, which is on Tuesday, and it starts at 11?
Yeah.
It starts at 11, that's what it says on the syllabus? Okay. So it starts at 11, it goes till 1:45? Yes.
How many questions you're gonna find?
72. No, I don't know yet. I don't know. I haven't made it yet. Yeah, I haven't made the final.
Would it be 7?
72. I said 72.
The date of final.
The date? It's a week from today. It's a week from today. What I'm going to do when I make the final is I'm just going to sit down with this. And I'm just going to kind of go through it and pick the problems I like. I did add stuff here from 11.2. At the very bottom, that's parabolas. 11.3 is the ellipses, so those are on here. Partial fractions are on there. You don't want to do a partial fraction problem? You don't want to do one of those right now? If you feel like you're completely fine, you want to leave, I'm not going to keep you here. You can go. You're not going to hurt my feelings, but then just, Wait a minute. Wrong page. 908. 908. You pick a problem from 908. Which one? Which ones?
The ones we did last.
No. No. I'm still trying to do some corrections for my Cal 1 class. I haven't finished their corrections yet. Which one?
25?
25?
No?
Oh, I don't care. You pick.
I'm waiting for people to say otherwise. Otherwise, that was
So 25 is not on the list, though. And that's,
is it?
I don't believe
You
it
want
is.
to be on?
No, I don't care if it's on. I don't care what you pick whatever. You want 37?
Sure.
That's on the list. Okay, we'll do 37. And I've got, what, about 10 minutes? Let's see how quick I can move through this. By a show of hands, how many of you feel like if I gave you a complete blank unit circle, that you could completely fill it out of your head? Maybe. I'm just wondering, I'm just wondering, if I would have asked that like a week after I introduced you to the idea, I think we would have only had a few people raise their hand. I'm hoping that by the end of the semester now, that you could generate that circle on your own without needing any other reference. All right, 7x plus 3 over x cubed minus 2x squared minus 3x. And you're asked to do partial fraction decomposition on this. This is number 37 on page 908. All right, so first thing I do is I check to make sure the degree of the numerator is smaller than the degree of the denominator. If it happens to be the same, or if the numerator's degree is bigger, I'm going to have to do long division first. But I don't, not in this one, all right? So I move on, and what I do is I try and factor the denominator. And do you see how you can factor that? In GCF? They all have an x, right? So let's at least pull an x out. That's not so bad. Now, can you factor the remaining quadratic? Does it factor? Yes. what does it factor to be? X plus 1, x minus 3. Or you could say x minus 3 times x plus 1. The order of that doesn't matter. So we are completely factored now, aren't we? And we have 3 distinct linear factors. And we have distinct linear factors. We're going to create our partial fraction decomposition over here. And for each distinct linear factor, we will put a letter on top. So it's going to be, you tell me, a over x plus b over x plus 1, and then finally c over x minus 3. Just so you'd see this, all right? Just so you'd see this. Let's just say that this had been plus right here, okay? If this had been plus, then this would have been plus here, right? And this would not have factored then. If that would not have factored, then what you would have is a linear factor and an irreducible quadratic, right? And then your breakdown would have looked like this. A over x plus bx plus c over that irreducible quadratic. That's what it would have looked like had this been a plus. And you couldn't break it down. You couldn't factor. Understand? All right. But that's not what happened. So, all right. Now, we take this expression right here, and we clear out the fractions, right? We multiply both sides by the LCD, which will leave you with the numerator on the left side. And on the right side, do I need to write it down what I'm doing here? Or do y'all know what I'm doing? Multiplying both sides by this, right?
Yeah.
So when I hit this side with this, it goes away. When I hit this term with this denominator, the x's cancel. I still have the x plus 1, the x minus 3, and the a. So a, x minus 1, x plus 3. Oh, x minus 3. Oh, I got those wrong. Plus 1 minus 3. And then when I hit this one with the common denominator, the x plus 1 goes away, but we still have the b, the x, and the x minus 3. And when I hit this one, the x minus 3 goes away, but I'm still left with the x and the x plus 1. Any questions on that step? Because I'm not showing some work there. Sure? Okay, now what? So you have two choices here. You can either distribute things out, try and do the system of equations, or you can try the shortcut where you try and start killing things off. It's your choice. And in this case, anytime you have distinct linear factors like this, and this comes out real clean like that, you should be able to do the quick shortcut method. So do you have a preference on how I show it? Let's take a vote. How many of you want the shortcut? Okay, how many of you want the expand everything out system of equations? Okay, whatever you do, but I'm going to do the short way because that's what you voted for. All right. So for the short way, I'm going to let me try and figure out what A is. And to get A, I need to kill off both the B and the C terms. Is there an X value I can pick that'll kill this, but not kill this? X is 0. If X is 0, it'll kill both of those. So I let X be 0. And when I let X be 0, I have to rewrite the entire thing again, right? Replace all my X's with zeros on both sides of the equation. So if that's 0, we get 3 on the left side. Here we get A times 0 plus 1 times 0 minus 3 plus, and then all of this is gone, isn't it? Everything else is gone. This is zeroed out, doesn't matter. So what is that coefficient on A? Like when I put these two together, what's the number going to be out here in front of A? Negative 3? So negative 3A. So 3 is equal to negative 3A. Divide both sides by negative 3 and you've got A, right? A is negative 1. Now we go try and get B. So if I'm going to try and get B, I need to kill this off and this off. So what can I pick? How can I choose X to kill this and kill this but not kill this? Negative 1. If X is negative 1, we rewrite everything. We get negative 7 plus 3 equals, this part's gone. This part's not. So I have B times negative 1 times negative 1 minus 3. And then the C part's gone, isn't it? This gets killed off. So I'm going to get negative 4 on the left side. On the right side, let me see. That's negative 4. But then another negative multiplying it, that's going to be positive 4. So I get 4B on the right. Hey, B is negative 1 also. Kind of boring. B is negative 1. Questions on that part? We're good? Now let's get C. So to get C, we got to kill these two. So what's X going to be to kill these two? 3. So 3 will kill this and this without killing that. So we plug 3 in all the way across. And when we do that, we get 7 times 3, which is 21, plus 3. This one's gone, and then just 3's in right here. So C times 3 plus 1. 24 on the left side. Right side, 4 times 3, 12C. Okay, so C is 2. Final answer is not that. Your final answer is this rewritten. Your final answer is negative 1 over x plus negative 1 over x plus 1, and then plus 2 over x minus 3. Good. That was a good question. Now, that was the shortcut method. I would be prepared to have something that's irreducible in there, which would mean you would need to distribute. And then you need to be able to use a system of equations and solve. Now, how many of you don't have the calculators? How many of you don't have the ability to do RREF? Oh, we never figured that out. Do you have time after class or no? You do? Okay. You don't have one, right? The calculator, remember I showed you how to do RREF? You don't have a calculator, right? Okay, so if I provided one, you'd be okay. Who else would need me to provide one on the final? Do you still need one, or do you have one now? You're good now? Okay. So I'll have a couple of extras. All right, that's it for today. Thursday, I'll try and come up with a little 10-question little sample test. Come with questions, though, please.